Hi, and welcome to this lecture about C# programming in Unity. In this lecture, you will learn what is C#, why we use it, the difference between syntax and semantics, the compiler, and order of execution in Unity. C# is a powerful and versatile programming language that's widely used in various domains, including game development. Unity uses C# as its primary scripting language due to its performance, flexibility, and extensive libraries and frameworks. C# is a high-level language. High-level languages are easy to learn and are close to a human language. Also, they are independent of the hardware that the program will run on. The same set of instructions that you write may be executed on different hardware and operating systems without the need to address the memory and CPU constraints of this particular hardware. However, it needs to be interpreted to the target hardware. Unity does all this for us. You just need to write the C# code, and the interpretation and compilation is handled by Unity for the target platform. C#, as any language, has a set of rules that you need to follow in order for the program to be compiled and executed, which is called syntax. Syntax is defined as the structure and composition rules of a programming language. It specifies how code should be written, including the arrangement of keywords, symbols, and punctuation marks, exactly like grammar rules for a natural language like English, for example. Semantics refer to the meaning of the program or what it does. Semantics mean the behavior and outcome of the program. For example, you may write a program with the intent of calculating the multiplication result of 2 multiplied by 2. But instead, you divided 2 by 2 in your code. This means the program doesn't perform the intended task correctly, although the syntax of the program is correct. The compiler is a computer program that interprets the code that you wrote in a human-readable form and converts it to a machine language that can be executed by the computer. It does this by parsing the whole code and checks it for syntax errors or undefined variables, and will stop compiling when it finds an error and tells you. However, the compiler doesn't check for semantic errors because only you know the purpose of the program and whether it produced the intended outcome or not. C# is a type-safe language, meaning variables must be declared as being of a particular type, and each variable will hold only its declared type. There are many predefined types in C#, but you can also create your own types. The most common types in Unity are int, which is short for integer, float, double, string, and bool. There are also Unity-specific types that we will explore later, like camera, animator, game object, transform, etc. When you create a C# script in Unity, it comes pre-populated with a few lines, including start and update functions. To understand start and update, you need to understand the Unity's order of execution. As you can see, Unity has created a very useful diagram to show the order of execution. It's divided into sections. The first section is initialization, second is physics, then input events and game logic, then scene rendering, then gizmo rendering, GUI rendering, end of frame, pausing, and decommissioning of the script. I will keep the link for this diagram in the video so that you can take a look at it later. You need to understand the order of execution as it will help you a lot. Back to the starter code in Unity. For example, if you move the update function above the start function, it doesn't mean that Unity will execute the update function first, as it will follow the order of execution. Also, if there is an awake function that you added here, it doesn't mean that the start function will be executed first, but the await function will be executed first because this is the order of execution in Unity. In the next lecture, we are going to talk about working with variables. See you in the next lecture. Thank you.